Good morning everybody and welcome back to this channel. So today we will be building the prototype for our device. We are using the Datalogger Feather M0 and the MAX31855, and this is the IC, a very small package actually. This is K-type specific for digital converting the value of the thermocouple. And I'm writing here for you the pinout, so we will have the ground on the first pin, on the first the 3.3 volt. On the right side of the chip there is the digital communication bus, and the central two pins on the left side are for connecting the thermocouple. Okay? So how can we place this IC in contact with our Datalogger? I'm building here a small shield using perfboard. The quickest way to snap the perfboard is by scoring a line along the whole line, okay? And you have to score on both sides, as you can see here. So I tried to snap it before scoring the other side and it worked. After we snap the board, and you see the size is right, I will see the size of the IC and mark out where I want it to be placed. And you see I'm marking the how wide the chip is, and I'm leaving 2 lines of hole on the sides, and using a cutter here I'm just taking out the copper from the holes where I want to place the IC. The idea here is to be able to have an insulated area where the IC will be placed, and the copper on the side, on each side of this insulated area, will be used to connect some small wires to the pin of the IC and get them in contact with the microcontroller. So you see, the size is perfect. I'm using a little bit of Loctite to secure the chip in place. In this way it will not move when I'm going to solder the pin. Now I will install some female header on the Adaruit Feather. It's very easy, you just have to secure them by soldering at least 2 pins. And then I keep welding them. I give you an advice here. It's very useful to have a flat point for the soldering iron, and when you are soldering you just heat up both the pin and the ring, and then you place the solder. That's the best way of not having cold junctions here. Then I place some male headers on top of the female headers, and this is the easiest way to weld them to the perfboard and have the correct spacing. Couple of solder can do the job. Now let's go to check out where we want to connect each pin. So the 3.3 volt and ground of the Adaruit Feather are on the first and last pin of this side, as you can see from the drawing. And on my IC, unfortunately they are swapped. So the first one is ground and the fourth one is VCC. And then in the middle I will have a thermocouple, and we also need to place a capacitor between ground and VCC. On the other side we will use a female thermocouple connector. I'm using 2 wires here that I will solder in place. I always pre-tin the extremity of the wire, so I don't have small wires going around. I insert them, I secure them in place by welding, cut the extremities, and I'm using the central part of a very thin wire. I need to change the tip of my soldering iron with a smaller one, because this is a precise job. I'm here placing some solder to the pin, and here I make a mistake because I applied too much and is shorting the 2 pins. I try to remove it with 1 wire, but it's not working, so I go with the solder wick. This is a magic trick. This is super useful when making prototypes. Then back to the soldering action. Oops, did it again. Okay, now with the very small wire, I always need a little bit of solder on the tip of the iron, and I just connect the small wire to the just soldered big wire. And here it's very interesting to see how the soldering alloy works, because it is liquid, of course, when it's melted, so it will work by capillarity. If you place a very small wire, the liquid will follow the wire. So this is a very useful property to use when you are soldering this very small chip. I always visually check during the process if I'm not shorting out anything, or if there is no contact, but of course we will check later with the multimeter. Then comes the capacitor. I am placing it front bottom because it's easier. On top we have a lot of tin, and I can very easily have short circuits. I always try to use the legs of the component to make a conductive path if possible. So for the ground that is very close, I'm using the leg of the capacitor to make the contact. Also, it's very useful to use the holes of the perf board to secure the wire in place, just placing a little bit of solder on top. And here I'm also using the thin wire to connect the ground part to the IC. For the power supply, I'm also using the leg of the component to this time get in direct contact with the pin of the IC. And since VCC is on the other side of the board, I will be using a wire that I will cut to size and pass from the bottom of the board. The wire is exiting from an insulated hole, but just a little bit of soldering paste is sufficient to secure it. Then I cut it to size, marking where I want to take out the insulation. Pre-tin the wire. Pre-tinning is very useful because it avoids to have wire that goes around and do not fit in the hole perfectly. And just solder it to the 3.3 volt. Okay, now we have the 3.3 volt here and the ground connection here. Also, on the other side, we have the capacitor. Perfect. Now let's get to the digital connection. The serial protocol have the clock line, SCK, then the chip select and the serial out or master-in serial output. Master-in serial output for the microcontroller, and these are these three pins, sorry. So I'm marking out which pin I want to connect where, and I just anticipate to you on the final version of these, I will not be using these pins, okay? There is a different pin out because these master input serial output and clock is shared between also the TFT screen and the SD card. So I had some problem with the communication and I had to swap them after that. Here I'm marking out the pin. The chip select is on the right side and the other ones are on the left side. So I prepare some conductive path here by cutting to measure and bending some conductive wire that I pre-tin in order to make the connections. The first one will be the master input serial output. As before, prepare the conductive path, and then the last part that goes to the IC pin, I use the very thin wire to make the contact. For the chip select pin, I choose to use one digital output. So I just use the thin wire because it's much closer to the pin that I want to connect. And now I connect the female header for the thermocouple. These have two screws inside, so I have to open it. I cut short the wires, I take out the insulation, and then I secure the wire inside the connector. Here an advice, since it's very easy to have a false contact if you do not secure it very well, I strongly advise you to check if the wire is tight inside. So when you fasten the screw, try to pull it a little bit, the wire. If the wires come off now, you can secure it back, and if you do not do this check, you can have issues later with very noisy signal or also no signal at all, and you do not know why. So be very sure that this is secured. I place also the rubber ring that helps to secure the wire in place and close everything up. Okay, and that's our connection done, and we are ready to test the part 1 of this hardware, just checking out some electrical connection here before closing it up. So next we will write some firmware to check if this works correctly. Thank you and see you on the next video.